Welcome to the Professor's DuBois channel. This is Professor Corey, and this video is a mini lecture based on our third lecture covering material from Chapter 6. We start this lecture talking about quantum mechanics, and for our purposes, we treat quantum mechanics as a black box. Each electron, through quantum mechanics, will be given a set of quantum numbers. These quantum numbers will serve as the address or the location for that electron. You can see on the right, the quantum numbers are n, l, m sub l, and m sub s. The first quantum number is the principal energy level and is represented by the letter n. We have seen this before with Bohr's model explaining bright line spectra. The value of n closest to the nucleus is 1, or n equals 1. The values increase by 1, and as a general rule, we can say that the higher the n value, the greater the potential energy. It's good to think of potential energy as distance from the nucleus in this case. Potential energy increases as we move farther from the nucleus. Our periodic table can be used to determine the n value for the outermost electron for any element. For the main group elements, n is equal to the period. We can determine the n value for transition metals using period minus 1. If you look at iron, Fe, you can see that it is in period 4. Since it is a transition metal, the n value is the period minus 1, or 3. The lanthanides and actinides have n values equal to period minus 2. You can see the n values on this periodic table along with letters, and we'll address the letters next. The second quantum number is represented by the letter L and is called angular momentum. I prefer to think of this as the shape of the electron cloud. If L is 0, we call this an s orbital. S orbitals have a spherical shape. If L equals 1, we call this a p orbital. P orbitals have a dumbbell shape. L equals 2 is a d orbital with a cloverleaf shape, and L equals 3 is an orbital with many shapes. You will want to memorize the L values with the SPDF designation and the shape. We will again use the periodic table to assist with this. The light blue colored elements are called S block. L equals 0 for the outermost electron of any of these elements, and the shape of that orbital is spherical. The P block, or L equals 1, are in yellow. The D block, or L equals 2, are in green, and the F block, or L equals 3, are in pink. Let's practice what we've learned so far. What are the N and L values for the outermost electron for fluorine? Pause the video while you think about this. Fluorine is a main block element, so the N value is equal to the period number, which is 2. Fluorine is in the P block, meaning the outermost electron has an L value of 1. So the answer would be N equals 2, L equals 1. So what is the shape of the orbital containing the outermost electron? Pause if you need time to think. The orbital is dumbbell shape. This corresponds to L equals 1. Try this exercise for cobalt. Pause the video if you need time. Cobalt is a transition metal in period 4. Therefore, N equals 3 and L equals 2. This is a d block element, so the shape of the orbital containing the outermost electron is a cloverleaf. Again, take the time to learn the relationship between L value, SPDF, and shape. This will pay large dividends as we move forward. This image shows what the shapes look like. 1s means n value is 1 and L value is 0. We can see the spherical shape of this orbital, and this orbital can hold 2 electrons. Notice how the 2s orbital is larger than the 1s, and the 3s is larger still. This is expected. As stated before, the potential energy increases with increasing n value. There are 3 p orbitals. These are the dumbbell shape, and there are 5 d orbitals with a cloverleaf shape shown. Each image represents an orbital, and each orbital can hold 2 electrons. In the following lecture, we'll discuss the remaining 2 quantum numbers, and this will help explain why there are 3 p orbitals and 5 d orbitals. At this point, you should be able to use your periodic table to give the n value and p value for the outermost electron for any element. In addition, you should be able to describe the shape of the orbital in terms of sp, d, and f from the L value. Thanks for watching. Please give the video a thumbs up and subscribe if you would like to see more mini lectures on the Professor's DuBois channel.